All right, here's how you do question number one of lesson 3.01a. It's about these exponent rules or laws of exponent that we learned in module one, the zero exponent. Any base except zero, any base to the zero power is always one. The next one is called the negative exponent rule. Any base, again, except zero, any base to a negative exponent, you're going to do the reciprocal. You're going to flip the base. And then when you flip the base, the exponent turns back positive. And then we have the power to a power rule that says any base, again, except zero, raised to an exponent, and then all of that raised to another exponent, you keep the base and you multiply the exponent. And that's what we're going to do here in problem number one. I'm going to do something different instead of using the same problem. Let's say I give you x to the negative third power. See, that one I'm applying the negative exponent rule. Basically, what I'm going to do, imagine this is over 1. Negative exponent means I'm going to flip the base. So whatever's on the bottom now is on the top. Whatever's on the top now is on the bottom. And then I change the exponent from negative to positive. And that's it. That's how you do problem number one. Let's go to the next one. Problem number two, very similar. Again, we're going to use the negative exponent rule. Okay, we're going to use that one. I'm going to change the problem. I'm going to use a different letter, different exponent. So let's say we have 1 over x to the negative 4 power. Every time you have negative exponent, it basically means we're going to flip the base. So basically here, what I'm going to do is I'm going to take the top, put it on the bottom, put it on the top. That's what I mean with flip. So we're going to have now x over 1. And then the exponent of the x, I'm going to give it back to the x, but positive. Now start getting used to that in algebra. When you have a fraction over 1, it's just the numerator. So I'm going to just write x to the 4 power. That's how you do this problem, problem number two. Let's go number three. Okay, here's question number three. And basically, we still working with negative exponents. And remember, when you have a negative exponent, you're going to take the base and you're going to flip it. Whatever's on the top becomes on the bottom. Whatever's on the bottom goes to the top. So here again, I'm going to change the letters. So let's say I use a to the negative 3 over b to the negative 7. You can see that both of these bases, base A has a negative exponent, base B also has a negative exponent, okay? And when you have negative exponent, it means you're going to flip. You're going to do the reciprocal. What exactly that means? That whatever base that is on the top with a negative exponent is going to go on the bottom. And whatever base that is on the bottom with a negative exponent is going to go to the top. Okay, so when you do that, you're flipping. Okay, now you're going to have a new fraction. Whatever was on the top, I have a to the negative third power. Now it's going to be on the bottom, but the exponent is going to be positive. And on the bottom, I have b to the negative 7 power. Now it's going to be on the top. That's going to be b to the positive 7 power. So I'm just flipping and changing the exponents to positive. That's how you do that problem. Let's go question four. In question number four, we're going to be using now what is called the power to a power. And basically means when you have a base with an exponent and all of that raised to another exponent, you keep the base, you multiply the exponent. That's what I'm going to do in this problem here. So again, I'm going to change the numbers. Let's say I use y. So y to the second power and all of that, that's what I put in parentheses, raised to the negative third power. So what I'm going to do is I'm going to keep the base, and here the base is y. And what I'm going to do is I'm going to multiply the exponent. So I'm going to get y to the negative 6 power. You can put that as your answer, or you can apply to your answer. You can apply the negative exponent rule, because every time you have a negative exponent, you're going to do the reciprocal. So imagine this is like y over 1. With negative exponent, we're going to flip, and then we're going to turn the exponent positive. Give it back to the y, but a positive exponent. And that's how you do problem number four. Let's go to the next one. Question number 5, very similar like the previous one. We're going to apply the power to a power rule again. Okay, every time you see a parentheses, one base inside the parenthesis with an exponent and an exponent outside the parenthesis, that's the power to a power. And basically we're going to keep the base, multiply the exponent. So I'm going to change the letter. Let's say Z, could be any letter, it could be any number. The base could be any letter or any number. Let's say it's Z to the third power, and then all of that raised to the 12th power. So what we're going to do is we're going to keep the base, which is the Z. So I'm going to keep the Z. And what I'm going to do now is I'm going to multiply the exponents. So what is 3 times 12? See, that's what I'm doing. I'm multiplying these two. Okay. Use your calculator if you have to. That will give me 36. And that's it. That's the answer. Problem number 5. Very similar one. And problem number 6 is again using the power to a power. But we're going to apply or use this rule, power to a power, twice. Okay, so again, I'm going to do something similar. Let's say you have parentheses a to the 4th, and then all of that raised to the 7th power, times, now we're going to have a different letter inside the parenthesis. So let's say it's b to the 5th, and then all of that raised to the 6th power. Okay, so what you're going to do is you're going to apply the power to a power rule to each one separately. I'm going to start with this one. Okay, so I'm going to keep the base, I'm going to keep the letter A, and then I'm going to multiply the exponent. So 4 times 7 is 28. Then I'm going to keep this dot. This dot means times, not the decimal point, times, center dot. And now I'm going to go to this parenthesis. I'm going to go now here. I'm going to do this one now. And I'm going to keep the base, I'm going to keep the b, and what I'm going to do is multiply the exponent. So 5 times 6 is 30. That's it. That's how you do problem number 6. Let's go to the next one. Problem number 7, now we're going to start using the zero exponent rule that basically says any base except the base cannot be 0. Any other number or letter except 0 raised to the 0 power, the final answer is 1. So again, I'm going to do something similar like number 7. Let's say you have in the parentheses a squared times b to the 6th power. But all of that, see, that's what is put in a parenthesis, is raised to the 0 power. Now, all of this, everything in the parentheses, is raised to the power of 0. And by the 0 exponent, that means that all of this is 1. And that's how you work this problem. Let's go to the next one. Here's the last problem, problem number 8. Basically the same thing I did previously. Here we have a fraction, and we're going to apply the 0 exponent again. So let's say I give you a to the 4th, b to the 9th, but then all of that fraction, everything inside, is raised to the 0 power. So like I said in the previous problem, any exponent that is 0, when the exponent is 0, any base to the exponent, and the exponent is 0, the final answer is going to be 1. So all of this, everything in the parentheses, is raised to the 0 power. But by the 0 exponent, that will be 1. And that's it. That's how you do this assignment.